Okay, in this class, we'll be talking about cosine rule, the proof of it. Okay, now we have a triangle, which of course is not a rectangle triangle, and to prove it, let's recognize the sides. This is B, of course, this is going to be a B, the side B, and this is C, this is going to be the C, and this is A, this is going to be the A. Okay, now we also have to create on the height, identify the height. So we have that, which is always perpendicular or at right angle. Okay, it meets it at let's look at the point D. Okay, that divides this side A into two parts. So we could label this as X, and if this is X, of course, this is going to be A minus X. Okay, now what you need to apply here is the Pythagoras theorem to these two different triangles. And let's not forget to label this as height, which of course it is. Okay, now the Pythagoras theorem, applying it to this right angle triangle ABD. In this triangle ABD, applying Pythagoras theorem, c squared, which is the hypotenuse square opposite the right angle, c squared equals to x squared plus h squared. You can see that? Okay, so this will imply that h squared will be c squared minus x squared. Okay, just making h subject of formula. So let's try it in the other triangle. B squared is equal to h squared plus a minus x squared, all squared. Okay, now h squared here, this implies that h squared will give us b squared, we're arranging the formula, minus is a minus x all squared. Now this from here to here is a minus x. You understand why from here to here is x. Okay, so we have two formulas here, 1, 2. So this is for this triangle ABD, this is for this triangle ADC. Okay, now that you have the two, one will now say if h square and h square, of course they are the same, that means this and this are also the same. So it simply means these two, c squared minus x squared is equal to b squared minus a minus x all squared. Now, if that is, we can expand this. In expanding this, you have c squared minus x squared equals to b squared minus, so let's expand this, that will give you a squared, that will give you minus 2ax, and that will give you plus x squared. Now, taking out the brackets, this minus is going to affect all the signs there, so you have c squared minus x squared will give you b squared, so taking out the bracket, you have minus a squared. This becomes positive plus 2ax, and that becomes negative minus x squared. Okay, so you have minus x squared on this side, and you also have minus x squared on this side. They cancel out. So we are left with c squared equals to b squared minus what? A squared plus what? 2ax. Okay, now x can be replaced with something there, but before we replace it, let's try to make b the subject of formula. Or first of all, let's replace x and know the reason why we should make b subject of formula, because we're just trying, you're just playing with the algebras in a triangle. So using your soccer tool, x, this is it. This is x, so we can use cos. Cos relates adjacent x and c, so bear this in mind. This is 3, equation 3. Okay, now the new stuff, sine b is equal, no, we have to use cos. Because sine will relate h and c. It is this x we're trying to eliminate, so we have to use cos. Cos b is equal to x over c. So x, if you arrange, c comes here, so you have c cos b will give you x. So you can, this is equation 4. So you can put this, replace this x as c cos b in this. So you have c squared equals to b squared minus a squared plus 2a, then c cos b. Okay, so all we just need to do is rearrange this formula so that we have b squared on one, or making b the subject of formula. Okay, so that means you take all this to the other side. So you have c squared here, this comes there, that's plus a squared, this comes there, that's minus 2ac cos b, leaving b squared on the other side. So it's more or less still the same thing I just saying, bringing your b, just swapping positions. So b squared gives you c squared plus a squared minus 2ac cos b. Now this is the cosine rule. If you repeat this, of course, in other ways, you will get the value for the other side. So in a triangle where you have A, B, C, of course this is A, and this is B, and this is C. In a triangle where you have this formula applies, says a squared equals to the sum of the other two squared, or let's analyze this, b squared equals to the sum of the other two squared minus 2ac cos its angle, the angle included. You understand that? So let's write out the three formulas. If you want to work with a squared now, a squared will be equal to the sum of the two squares, which is b squared plus what? C squared, then minus 2bc. You see that? Okay, let me not put it in bracket, so it doesn't, whether I put it or not, doesn't change anything, but just don't want to. 2bc, then cos A. So if we do that for, we already know B, if we do that for C, C squared will be the sum of the squares of both sides, that's A squared plus what? B squared minus 2AB cos its angle, C. The angle included, that angle there. So if you are dealing with, looking for C, you will deal with this angle. If you're looking for B, you deal with this angle. If you're looking for A, you deal with this angle. Okay, maybe I should write B down there now. B squared will give you, swap that, that's A squared plus C squared minus 2AC cos B. Now, if you are looking, this is the cosine rule, of course. If you arrange this, let's assume that you're looking for an angle, just rearrange this. You have cos A. If you're looking for the angle, cos A will give you B squared, that's just rearranging this. Cos A will give B squared plus C squared minus A squared all over 2BC. Now, if you arrange this, the same thing, cos, or let me rearrange B. Cos B will give us A squared plus C squared minus B squared over 2AC. And cos C will give you A squared plus B squared minus C squared all over 2AB. Now, this formula enables you to use enables you to find a side when you are given the other two sides and the angle included. While this formula enables you to find an angle when you are given the whole sides. Thank you for watching, and we'll move to the next class now.